here, we distributed 4x cubed, 4x squared minus 24, negative 6 plus 9x squared. At this point, we are adding and subtracting, and we have to start with the degree. The degree is 3. So 4x cubed minus 6x cubed is negative 2x cubed. 4x squared plus 9x squared is 13x squared. And negative 24 is the free term, free of variables. And that's the simplified form. Trinomial, degree 3, negative 2x cubed, the leading term, and negative 2 is the leading coefficient. Any questions? Okay. Moving on to 5.4. 5.4 has two parts in practice, A and B. So we're going back to exponential rules. Anyone remembers 7 to negative 3 multiplied by 7 to negative 5? What will that be? Which power or exponential rule applies here? We copy the base. What happens with the exponents?
You add them in negative 8.
Yes, indeed.
Exponent's going to be negative.
Exactly, 1 over 7 to the 8th. So as we know, 7 to a negative number is simply a condensed form of a fraction. And the fraction is 1 over 7 to the 8th power. And the rule again is a to negative n equals 1 over a to the n. Good. 4 to the 9th over 4 to negative 6. Can anyone give us or tell us the rule that we apply here? We copy the base. What happens with the exponents? Again, we cannot divide them if they don't have the same base. Luckily, they do. So I can copy the base, and what happens with the exponents?
We subtract it?
Yes. Always from 9, from the exponent of the numerator, I subtract minus 6, the exponent of the denominator. So this is indeed 4 to the 15th power, which cannot be changed. It's not a negative exponent. Okay, so let's look at slightly more sophisticated problems. Negative 6x to the 9th, y to the 5th. Everything divided by negative 2x squared, y cubed. Always address the signs first, the numbers second, and then the variables. I want to mention something here. If you remember, we said the denominators cannot be 0. So the correct attachment to the answer is this. So here's a reason why. When I divide 2 by 2, I get 1. I do not have to write that 2 does not equal 0. Of course not. 2 is not 0. But if I have x over x, I know the answer is 1. But it is 1 only if x does not equal 0. So we call this restriction on the variable. The variable x is restricted. Why is it restricted? Because it cannot be 0. It can be anything else, but not 0. Division by 0, as we know, is considered or named undefined. Good. So let's start with the signs. Can anyone give us the sign, the resulting sign? And then the numbers. Divide the numbers and tell me what you write to write in front. Please, anybody divide negative 6 by negative 2, please?
3.
Good. So now we reach the level of x, or the step in which we look at x if you want. So I copy the
7th power?
exactly. Now I finally reach the y's. Notice that if they don't have the same base, I cannot use any exponential rule.
Y to the second?
Y to the second power, and this is the final form of the answer, including, so it's incorrect to say the answer is 3x to the 7th y squared. The correct answer is 3x squared, 3x to the 7th y squared, only if x and y are never 0. Good. Let's move on. So you will see there are several examples, and I really like those in Pearson. I tell you when I dislike what they wrote, but then this particular one, I'm going to move on to the next page. I really like. It's a very good comparison. It gives a wide explanation of what's happening here. It touches up on everything. I love this exercise. 4x to the 5th plus 2x to the 5th. Then 4x to the 5th times 2x to the 5th. And then 3x to the 5th, everything to the 5th power. And the last one, 3x to the 5th over 11x to the 3rd. So you will find something similar in several problems in Pearson, in the practice. Obviously, they're all different. Here I have a sum of terms. Here I have a product of factors. Again, sum of terms. Product of factors. Here I have a term raised to a power. And here I have division of two terms. So, what do we get on the first one?
6x to the 5th?
Yes, 4 apples plus 2 apples is 6x to the 5th. Excellent. What do we get on the second one?
Eight x to the 10th?
8x to the 10th. Multiply the numbers, copy the base, and add the exponents. Very good. I'll help with the number. 3 to the 5th is 243. So 3 has to be raised to the 5th power. Then x to the 5th has to be raised to the 5th power. Copy the base. I said 3 and I wrote 5. Copy the base, and what happens with the exponents? Which rule applies here?
Multiplication?
Exactly.
25?
Exactly. Good. 3 over
See,
11.
that one gets me. I always forget to do the 3 to the power of 5, so thank you.
They are in parentheses. We cannot pick and choose. All factors have to be raised to the power. Good. So 3 over 11 cannot be simplified. Now I copy the base, and what happens with the exponents?
5 minus 2?
Yes.
Or 5 minus 3?
Yes.
2?
Yes, indeed. Good. One exponential rule that we discussed a long time ago is this one. We had many numerical examples like this. Well, it's very simple. I have to raise the numerator to that power, and I have to raise the denominator to that power. So now let's work on negative b to the 5th over c to the 3rd and everything to the 4th power. Remember here we see 3 factors. This is a factor which is negative 1. This is a factor which is b to the 5th. This is a factor which is c to the 3rd. All factors have to be raised to the 4th power. Let's do that. Negative 1 to the 4th power is negative 1 to the 4th power is
Negative 4? Oh.
We're not multiplying negative 1 by 4. We are raising negative 1 to the fourth power.
So 1?
Exactly. Because this is a negative number and the power is even. So there is nothing I have to write. Good. B to the fifth to the fourth. I copy the base. What happens next?
5 times 4?
Yes. B to the 20th. Very good. I copy the base. What happens to the exponents?
3 times 4?
That's it. Here's another one that you will see in practice. 15 times 7 raised to 0. How
And
much?
we don't do anything with the 1? We don't put the 1 in front? We're just...
You can. But 15 times 1 is 1 times 15, no matter what you do. So this is 1. 15 times 1 is 15. What about negative 13 raised to 0? How much is this? How much?
No,
I couldn't hear you.
1,
Exactly. Good. Here's another one. Negative 13 raised to 0.
Negative 1?
Yes, because this is 1 that needs to be multiplied by negative 1 in front because it's not in parentheses. As we know, we learned this a long time ago. Parentheses, no parentheses. Parentheses, I have to raise what's inside to this power. No parentheses, I cannot do that. I have to raise 13 to 0. After I'm done, I multiply by negative 1, or I say the opposite of whatever answer. And yes, in this case, it's negative 1. Perfect. Good. Any questions? Any questions, please? Anybody? You don't need me to ask, please, if you have any questions. Let's say, always stop me. How do I rewrite y to negative 4? Anyone can tell us how to write y to negative 4?
One over y to the fourth power?
Perfect. Moving on. What about negative y to negative 3? Please stop me if you have questions. Always address the negative exponent first. Don't look inside. You don't care. First, apply the power, which is exactly the same thing, whatever I have to the third power. Okay, so I have negative y. Now, I raise 2 factors to the third power. One factor is negative 1, and the other factor is y. So let's raise negative 1 to the third power, and also raise y to the third power. What do we get?
Negative y to the third power?
Negative y to the third power. Now we have to put the negative in front because there is a positive here and a negative here. So this is the final form. So please never assume that when you see a negative exponent, the answer will be negative. It may, but do not ever assume that a negative power will result in a negative quantity. It may or may not. Okay, one more. Negative y to negative 3. Parentheses, no parentheses. How do I address this? What do I need to do first? The -1 is not under the umbrella of -3. So you have to wait. So keep -1 in front and then change this. How would I change y to -3? What does it represent?
One over y to the third.
Exactly, that's it. You cannot do anything else here. Good. So let's recap for a second. Y to -4 is 1 over y to the 4th. But if I have 1 over y to -4, so y to -4 is in the numerator. But what if I have it in the denominator? If an expression with a negative exponent is in the denominator, it will go to the numerator with a positive exponent. Here it was in the numerator with a negative exponent. It went down in the denominator with a positive exponent. If it has negative exponent and is in the denominator, it will go up to the numerator with a positive exponent. Please understand, this is very important. Since we are here, this happens identical to a fraction. So if I have a over b raised to, let's say, -3, I have to flip this b over a and change the negative power to a positive power. And this is the same rule. It looks different, slightly different, but it's the same rule. So if a quantity has a negative exponent, it will go to the denominator with positive exponent. If a quantity has a negative exponent and it is in the denominator, it will go to the numerator with a positive exponent. If a negative exponent is attached to a fraction, all I have to do is flip the fraction and copy the positive exponent. So let's practice this concept now.
And if the negative's on the bottom, is the top always going to be 1 still?
No, I just gave an example with 1. It can be 7. It can be anything. The numerator, if it has a positive exponent, I can never touch it. I can never move it anywhere. Whatever.
Just add it to the front. Thank you.
Yep. So if a quantity has a positive exponent, I can never touch it. I can never move it anywhere. Very good question. Good. So let's say 12 divided by y to -4. As you know, we don't like negative exponents in the final answer. So the same thing here. So how do I write this? How do I write this with no negative exponents?